All right. Again, guys, just as a reminder, if you are asked in section 6.1 to find a point estimate for the mean, you just find X bar. So if X bar is 70, you tell them 70 is a point estimate of the population mean. Okay, let's go to the example and we're gonna show you how to construct an interval. Suppose from a random sample of size 49, so N is 49, guys. We find a sample mean of $30. X bar is $30. It is known that the typical distance a value is from the population standard deviation is 35. So the population standard deviation sigma is 35. Construct a 95% confidence interval for the population mean. That's the confidence level. So guys, always in any confidence interval problem in this section, he's going to provide you with the sample size. He's going to provide you with the sample mean X bar. He's going to provide you with the standard deviation, whether it is a sigma or S, but in section 6.1, we assume it's sigma, and he's going to provide you with a confidence level, which is 95%. The confidence level here, 95%, means there's the probability that the interval contain the population mean is 95%, provided that we repeat this so many times. And I gave you an example. If we do 100 intervals, it is likely that 95 of them will contain the population mean and 5 of them will miss the population mean. And let me show you guys how to create the interval by hand. Okay, so here's how you start. It's not difficult at all once you know what to do here. So N is 49. Let me write them down. X bar is 30. Sigma is the largest standard deviation, 35. And confidence level, guys, we use C for it. It's 95%. I told you earlier that the mean is this. The interval is that X bar minus E and X bar plus E. This is given, guys. Sorry. All I need to show you how to find E. And E, guys, it has this formula that I came up with, if you remember a few minutes ago. In the book, they call it Z with a lower script C because this Z is based on the confidence level. So we're just going to put Z times sigma divided by square root of N. This is given. This is given. We just need to find that. And what's the confidence level, guys? 95%. Do you guys remember what was the critical value for a 95% confidence level? Does anyone still remember?
1.96.
Good. Here they are. I'm not making anything up, guys. It's already there. 1.96. If you memorize it, good. If you don't memorize it, we can do it. Look how we can do it. You take the 100% and subtract the 95. You get 5%. You divide it by 2. You get 2.5%, 0.025. And for ZC, you run inverse norm, 0.02501. I can assure you guys the answer is going to be negative 1.96. You just use 1.96. Now, maybe students will tell me, Mr. Bazzi, I want to use the negative 1.6. You could, because one time you're going to minus it and one time you're going to plus it. You're going to get the same result. So we always use the plus. So look, here is the E, guys. 1.96 times sigma, which is 35, divided by square root of N, square root of 49. And now, guys, probably you can recollect why when we did the algebra in chapter 5, I did some algebra and how to do a number divided by square root. Look, we're using it right now. So let's do the math. Clear. 1.96 times 35 divided by, what's the square root of 49? I'm not going to put square root of 49. I'm just going to put what? 7. There you go, guys. It's 9.8. And you're ready for the interval? Here's the interval now. Mean is between, you write it like this. X bar is 30 minus 9.8 and 30 plus 9.8. Mean is between 20.2 and this is 39.8. That is your confidence interval. Now he's going to ask you for interpretation. You're going to learn, guys, how to express yourself in writing. How would you write, just your results to a reader, someone who doesn't know much statistics? Here's what we write. You say, with 95% confidence. This is the language, guys, don't change it. This is the language of the book. You can say we are 90% confident, or you can say with 90% confidence. We can say, or you can say if you want, that the true mean means the population mean is between 20.2 and 39.8. And that would be the interpretation in your words for the confidence interval. And why it is important, guys, to make this interpretation. If you tell someone that the mean is between 20.2 and 39.8, this person is going to think that the mean for sure is between 20.2 and 39.8. But no, we're not sure. We're only 95% sure that this is the case. It means if you do 100 of those exercises, then it's likely that 95% of them will have the mean inside the interval, but 5 of them could miss, and that's what a 95% confidence means. You have to include this statement with 95% confidence. We can say that the true mean is between 20.2 and 39.8. And to show you what I did, guys, so that's the formula, Z sigma over. The plus or minus, guys, means one time I add E and another time I subtract E. So just if you want to just follow my work on the other paper, that would be even better for this one. So I'm just going to write it down here. I know that plus or minus could be a little bit confusing sometimes. 1.96 times 35 divided by square root of 49, which is 9.8. And your mean is X bar 30 minus 9.8 and 30 plus 9.8, which gives me a mean between 20.20 and 39.80. Because it's dollar amount, they do 2 decimal places. And with 95% confidence, we can say that the population mean is between 20.20 and 39.80. Any questions, guys, before I show you how to use technology now to do this interval? You're going to see how technology is done here. Okay. Watch. You ready? From now on, guys, where I go, this is where you're going to be going probably throughout the semester to do all the work on the calculator. So you're going to press on stat. And you're going to go to tests. Okay, guys, can you guess what the program name based on what we have done so far? It's on the main screen. Any?
7.
Which one? Number 7. Yes. We're working with Z and it's an interval. It's Z interval. Watch. Enter. Okay. Input. If he gives you raw data, you use data, but he didn't give me. He did give me a summary. Most of the time it's a summary, so it's a stats. Okay, guys. Sigma. What was sigma in the exercise? 35. You agree? I'm just going to go slow with this. X bar, 30. You need to know how to input the values, guys. That's why it's very important that you understand how to read the question and know what's given and what's not given to you. 49. Confidence level. You don't need to put 95%. 95 is good. 0.95 will also take it. So that's a 95. And hit calculate. I'm going to be in trouble if I don't get the same exact interval, but I'm very confident, guys. It's going to be the same exact interval. Ready? Calculate. There you go. That's the interval. 20.2, comma 39.8. Will you be allowed to use the calculator? That's fine, unless if the question is asking you to show all the work, and by finding the margin of error E, you have to go through the steps. But if you're doing your work online, it's just asks you to find a confidence interval, and you only need to input the confidence interval. You can just simply use the calculator.
Could you
The
show
challenge
the
is, which
calculator?
formula do you use? Any questions?
Can you show it on the other calculator? Because mine looks completely different.
No problem. Should be pretty much the same. There you go. This one, right? Clear. Stat. Tests. Number 7. It's number 7. Well, probably you put Z test, not Z interval. Okay. Sigma. What was sigma, guys? I forgot. 35. I'll do it again. X bar is 30. N is 49. Confidence level, put 95. And here you go, guys. That's the interval. Let's do another one. I'm gonna go take time, with this, so you can understand what we're trying to do here. Construct a 95% confidence interval for the population mean. So you guys agree with me, this is C. For the sake of the calculator, you need to distinguish each value. Assume that the population has a normal distribution, a sample of 25. What's the simple for 25, guys?
N.
N. Randomly English measures has a mean test score of 81.5. That's from the sample. We call it X bar. That's X bar. Assume that the population standard deviation is known to be 10.2. He says, assume that we know sigma. We usually don't know sigma, but we're assuming that we know it. So that's sigma. Round to the nearest 100th. Okay, guys, this is a walkthrough, guys. You're going to see, this is why I call it guided notebook. It walks you through the steps. List the given values, sample size. Okay, and I'll list them one more time. Sample mean, X bar is what, 81.5. Okay, here it should be population standard deviation. Please change that. Sigma is what, 10.2. And confidence level C is 95. Don't use the calculator yet. We're gonna do it using by hand method, and then we'll use the calculator.
Sure.
Okay. Find the critical value, guys. It's 95. Does anyone know what the critical value for 95? Remember, for 90 is 1.645. For 99 is 2.575. And what is it for 95?
1.96.
Yeah. If you can memorize it, guys, that will help you a lot. Compute the margin of error. Watch, guys. 1.96 times 10.2 and divided by square root of 25. Okay, let's do the math together. Now you're showing the work. We haven't used the calculator yet. All right. I'm gonna clear the screen and I do 1.96 times 10.2. You can do this first and then divide and watch. This is how you pick the square root, guys. You press second key and then the square root and 25. 3.9984. If you round this to 2 decimal places, it's going to be 4. And guys, this sign means approximately equal, not exactly equal. So just if you ever seen this sign, it means approximately 4. Okay, let's go to the rest of the page. Here you go. State the interval. You know X bar, guys, already, which is 81.5. Watch. Minus E4 and 81.5 plus 4. So the mean will be 77.5 and 85.5. That's your interval. We're done. Using the calculator. Let's do the calculator now. Stat tests. The challenge of using the calculator is the following, guys. It's very easy if you know which test to pick. But if you pick the wrong test, of the calculator, you're going to be getting the wrong output. So we're picking number 7. So I'm going to tell you guys, if you want to take a note, number 7, you can use this to construct a confidence interval for the mean when the population standard deviation is given to you. When you assume that the population standard deviation is known, you use the Z interval. So we're going to go to Z interval. What was sigma in this one? Sigma was 10.2. What's X bar? 81.5. I should get the same results, guys, whether you're using calculator or not. N is 25. Confidence level is 95. Oops, what did I do? Let me go back to stat. I pressed enter twice, so I lost. Number 7. And here you go, calculate. 77.50, 85.50 if you round to 2 decimal places. So we'll get exact same output as I did right there.
I have a question.
Mhm.
I use another calculator, and when I do the Z interval, the number 7, what comes up on mine is the input with the data, the sigma, and then underneath it is list and frequency.
Oh, you need to change. Oh, I know what you're doing. I know. Okay, good. Look what's happening with you. You need to fix this now. You see here? Remove data. You shouldn't have data. Just scroll to stats. Scroll to here. So go up and scroll to stats.
Thank you.
Got it?
Yes, thank you.
Yep. All right. Using calculator, so we got it. And now interpretation. Does anyone remember how to write the interpretation? Can you help me, guys? With, what do I write here?
95%.
95% confidence. We can say that the true mean, whatever the mean is about here, let me see, what is this? Okay. The true mean test score is between 77.5, 0.50, he said 2 decimals, and 85.50. And my summary here, I'm gonna write it down, guys. Use Z interval. And it's in the back of this handout. I put a summary of all those calculator shortcuts to construct confidence interval for the population mean when sigma is known. Sigma means population standard deviation. That's when we use a Z interval.